Hi all, this is Brendan and I'm going to be doing 30 days of Solidity. Today is day 10, so I will be a third of the way through once this is complete. Today we'll be doing the activity tracker, and as before I have already copied the task description from the Web3 Compass calendar for day 10, and here's also the addresses that I've from my wallet that I've copied across. So what this is going to introduce is the concept of structs, so grouping data together, different primitive types into a single new type that's from the smart contract. Also events, which are things that you can log. And we'll also be introducing a mapping of an array, or a mapping to a struct array specifically. And I think one other thing we will introduce, not necessarily required, but we're also going to have introduce bit shift operators, right? So let's begin. Before we dive into this, I'm going to get this. Actually, all of this stuff, right, from simple IOU, and I'm going to delete the stuff that is not relevant. I just basically want the manager and members related logic. Right? So, but add member, remove member, and then also have got only manager and only member modifiers, right? All right, so let's see. So this function mainly needs to have a log function, and inside the log function, it is going to keep track of the activities. It's going to store the activities that each member performs, and also tally a running total of the distance and the duration of the activities, and also detect when there has been a new milestone met. So let's begin. So essentially we've got add and remove member, so that takes care of that, and we're going to create a log function where all the magic happens. This smart contract is pretty much just this one function: public only member, and I think it's parametric, right? So it doesn't assume message.sentence. I'll just use that. And then I'll leave the implementation empty for now. And so when you log a message, there will be an implicit parameter of message.sender, so you know who is sending it. But we'd also like to do log of string memory category, so what type of activity it was. Maybe it was a run, maybe it was a walk, etc. uint 16 duration, and uint 16 distance. Now, whenever we've been using numbers in the past few days, we've been using uint 256 only, right? So why uint 16? So these are just different sizes of numbers, and they use less space in memory as a result, right? And we can do this, right? 2 to the power of 16 is 65,000, right? But if we do 256, it's this enormous number that we're never going to have that many seconds in a run, or that many meters in a run, for example, right? So 65,000 seconds it's I think almost a day, or more than a day. And then distance, that's like if each unit is a meter, then that would be 65 kilometers. So we're not going to exceed these numbers, not easily anyway. All right, so these numbers are big enough, right? We can bump it up to say uint 32 if we felt like it, right? All right, so anyway, we want to log the activity. So the very basic thing that needs to happen is we want to create a struct. So let's call the struct activity, right? And needs to be in memory, and because it's dynamic, and then activity. And what we'll want to do is to specify, so category is category, right? Duration is duration, and distance is distance, right? And we also want to use timestamp, right? So that will be block.timestamp. So we use an implicit parameter, right? We won't use message.sender here. All right, so now we need to define activity. Right. So let's just copy this and we'll paste it here before code. Now, what we need to define, this is the code that initializes an activity, but we need to define the struct, right, which is like short for data structure, right, which is just a grouping of these different values. So we'll have, actually I just copy this here and paste it here. All right, so we'll have category, and let's make that a string. And then I believe it's semicolons. And then for duration, we'll want it to be a uint 32. And for distance, that is also a uint 32 as well. And for timestamp, we want that to be uint 256. That one's got to match the type of block.timestamp. And that's our struct. Right, so we've defined the struct. And so now we will be able to construct a struct like so. Sure what that circle there does. In any case, next thing we want to do is we want to store that struct. So we can say, let's keep a list of activities. Message.sender plus equals, actually no, it'll be push. And we'd want to push in the new activity object. Right. And we also want to keep running totals. So it'll be total distances for message.sender. Then this will be, incremented from its current value by the value of distance that was passed in. So we're just adding it each time. Total durations will be plus equals to duration, right? Let's define these. So this is going to add a uint 32, but you can cast a uint 32 to a uint 256 because that number is bigger. So we'll store total distances and total durations as uint 256. And for activities, that will just be, we're going to push an entire activity. So it'll need to be a list of activities, right? An array. And all of them are going to be a mapping where the key is the address and the value is what I just said, right? So let's go and do this. Mapping address to something is public something, right? So we want 3 mappings of address to activity, public, and we'll call that activities, right, to match this. And we'll call this one total distances, and this will be uint 256. and this will also be U256, and that will be total durations. Okay, so now we have got activities and being pushed, and we've also got a running tally of total distances as well. All right. Finally, we'll want to emit an activity log. Right. So emit activity log. So this is an event which we've yet to define, and we want to do message.sender, category, duration, and distance. So essentially, we're trying the events that are being logged will be very similar to activity, except that it also includes message.sender but does not include the timestamp. Yeah, I think the timestamp activity logs have timestamps anyway attached to them, so that's a bit redundant. All right, now let's define the event. Just like how we define a struct, we also need to define an event. And the way to do that is event activity log, and we'll have this address. Actually, let's do multi-line. Address, member, I guess. Address member, and then string category, and uint 32, duration, uint 32, distance. Right. And that should do it. What's this error? Function variable struct. Declaration expected. Stray semicolon here. So a struct doesn't have a semicolon at the end of it. An event does. Anyway, syntax. All right, so now we've got an activity log. The thing is that while this activity log would work, what it doesn't have is indices. So in any event, you can say, I think it is up to 2 values can be indexed, right? It's just a keyword. Is it 2 or 3? I'm not sure. But in this case, I want to index both the member and the category. So what index means is that it'll store store it in a particular way in the event log, such that when a DApp or front-end client wants to search for activity logs, it can do so using through its indexed attributes. So for example, if you want to search by duration or distance, it's not going to let you do that. But if you want to search by member address, or I should say filter by member address or filter by category, it'll allow you to do that. Right? So you can pick which ones you want, which ones make the most sense. All right, what is this complaining about? Trailing comma. All right, another syntactical error. All right, let's compile. No errors. All right, let's deploy. All right, now we've got an activity tracker, and let's see. The admin is already a member, so let's do a log, right? So let's say category is run, duration is say 1, and distance is 1. So I ran for 1 second and the distance was 1 meter, for example. Let's just see that in action, right? So I've got a successful transaction, and I can see that this is the inputs, and more importantly, I have an activity log, right? So the event has been emitted. Now we can also query the activities, right? And so we can put in the address, and oh yeah, so we can see activity 0 and activity 1, for example, right? So we can see that's 1, 1. Now let's say we do I guess a 1 minute run, and let's say I covered say 200 meters in 1 minute. All right, let's press transact, and we can see, hey, there was another one, and there was also an activity log. Now, if we call activity for this address with 0, we'll get the same value again. But if we call it with index 1, then we will get that value. And that's essentially basically automatically generating this by saying, I'm going to query this address and make that the first parameter, and then the index of the list will be the second parameter. And so that's what it's doing. All right, that would be it. It's really that simple. If we just wanted to log activities and store them in a smart contract, nothing else. For example, if let's test the only member thing. So let's say I were to do that and change it to a different thing, and I try to log another activity, it will reject, saying only a member is allowed, right? So we got that basic stuff down. But I'm gonna kill that deployment, and I am going to write a new one, update this implementation. So what I want to do is something a bit more complex, where I define a milestone, right? So just like we've got activity log, I'm going to define a milestone log, and milestone. And what would I want in the milestone log? Right, I would want to keep member. I would also want to keep category, and I would want a number. Uint 256 number, right? So we don't know what that number represents yet, right? Because we'll be logging milestones based on both duration and distance. So we'll just have a milestone log that's fairly open-ended. And then we'll go to log, and we will modify that, modify the current implementation. So after I emit activity log, I'm going to say check if milestones have been hit. So I'm going to say if, and then some condition, and inside that condition I'll say emit milestone log, and the first parameter will be the member address, which is message.sender, and then I'll say some string for the category, and then I will say some value, right? Now, what do we want those values to be? I can think of 3 of them. So the first one will be the number of activities. So it will be activities dot length, right? So I'll call that activities. That will be the activities milestone. And the next one will be duration. Whoops. I have them out of order. Duration and distance. And so what I want would be total distances as the value, and total durations as the value. Right, so this is what I would want to emit. Now the next thing is to work out what the condition for that would be, right? And so I need a before and after this modification. So for comparison in for milestones. Alright, so I'll say uint 256 num activities is equal to activities for message.sender.length, I'll be essentially these things. Total distance. Alright, so we've got these three before values, and then after values will essentially be these things. And I'm going to do a comparison with bit shifts, right? To the bit shifts denote the milestones. And bit shift just, you can think of it as like similar to powers of 2 or powers of -2. But it's just an efficient way of dividing or multiplying by a number by some multiple of 2, because numbers are stored in binary. Okay, so this will be num activities. Right. Yeah, let's just copy this pattern, this comparison pattern. And I'm going to do num activities, total distance, and total duration. And this one will be the actual value, a current value, right? Total distance. Right. So essentially I'm doing a bit shift. If you shift it left by 1, then you effectively, shift right by 1, you're effectively dividing a number by 2. If you shift right twice, then you're dividing a number by 4. So every time the value of the number of activities or the total distance or the total duration quadruples, it is going to consider that to be a new milestone. I figure that might be an easy way to get an exponential curve going for the milestones than otherwise. Alright, so now I've got milestone logs and I've got the logic for those. Let's compile, no errors. Alright, let's deploy. So we've got a newer version of the activity tracker now, and I'm going to log a run, and the duration will be, say, 1, and the distance is 1. Right? And so you'll notice here that I have a activity log, and I do not have any milestone logs. Now, if I were to do a 3, so now the total will be 4, right? So if I do a transaction, if I transact that, and now I get an activity log, and I also get a milestone log. This one will be for duration, and the other one is likely to be for distance, and the next milestone log will be for duration, right? Now let's do an increment. So now currently, if you look at total distances, right, I'm gonna copy the address of the current total distance. Is interesting, 0. I'm using the second account. Sorry, my bad. Yep. Total distance is 4, and total duration is also 4, right? Because I did 1 and 3 each. Now let's say I do 2, so now they're gonna distance and duration is gonna be 6 each. If I press transact, right, there should be an activity log, but no milestone logs. Let's see if that's right. So activity log and no milestone logs. Excellent. All right. Now let's see. Total distance is 6 and 6, and so I'll need to log a duration of 10 and 10, and so that will bring it up to 16. And if I press transact now, then so now it's 16 and 16. Now if I do that, you should see that I have, ooh, interesting, no logs. Oh, sorry, that was those were the calls. Now if I press transact, yep, I do indeed get a transaction. And right, there you go, logs. I've got the activity log, I've got a milestone log, and I've got another milestone log for distance and duration. So working as expected. All right, that's it for this one. Thank you for listening.